All right, so we have this thing called the celestial sphere, which is a huge imaginary sphere on which all objects in the sky were once considered to be attached. You'll notice that you've got the planet here, the person standing here. If you put yourself on the planet, when we look up in the sky at night, or even during the day, it's as if everything is painted on this circle around us. You can tell as you look at the sky that there's this bend to it. But this canvas that it appears things are painted on is the celestial sphere. The sphere was once thought to be centered around Earth. Remember, the whole universe is moving around us. Although we know now that the Earth is not the center of the universe, or even the center of our solar system, it's just convenient to think of this imaginary sphere to describe apparent motion of the objects in the sky. Just as Earth has important points or features used for reference, such as the North Pole, South Pole, and Equator, the celestial sphere also has reference points. The North Celestial Pole, before we get to that, for the celestial sphere, this is a product that you can buy. It's kind of expensive, like $100 or something. But basically, you've got the globe there, and then you have all of these little dots are the stars in the sky, the bright stars in the sky. When you turn it on, it'll light up the room, and you'll see constellations. Pretty cool, but I think the most useful thing is just looking at it to understand what we're talking about when we talk about the celestial sphere. You have this clear thing around the globe, and this clear thing represents the celestial sphere. So again, we have the North Celestial Pole and the South Celestial Pole as the extensions of Earth's geographical poles into space. This is as if the Earth is oriented straight up and down, which we know not to be true. We know there's this tilt like a normal globe. But for pictures, again, looking at this, the North Pole goes straight to the sky, the South Pole goes straight to the sky. So this is our North Celestial Pole and the South Celestial Pole. And then this silver band around here is going to be the celestial equator. Just like our equator is exactly halfway between the North Pole and the South Pole, the celestial equator is exactly halfway between North Pole and South Pole. From anywhere on Earth, only half of the sphere is visible at a time, because the other half is going to be blocked out by the sun. So we can't see the stars behind the sun, unless there's an eclipse or something where the sky goes dark and then all of a sudden we see the stars behind the sun. We'll get to that. But for now, just know that you have half the sphere is lit and half the sphere is dark, so you can only see half of the stars at a time on the celestial sphere. Whichever hemisphere you are in, that is going to be what you're able to see. If you're at the South Pole, for example, you'd be able to see the entire southern celestial sphere. At points between the poles, you can only see part of the northern hemisphere and part of the southern. The horizon, which is where the Earth and sky appear to meet in the far distance, is a circle on the celestial sphere. So the horizon, as you look out, that is the circle where the Earth and the sphere appear to meet. Just as geographers use latitude and longitude to describe a location on the Earth's surface, astronomers use coordinates azimuth and altitude to describe the location of the celestial sphere. Azimuth is how far around the circular base of the hemisphere or how far along the horizon. So azimuth is like this. That's your straight up and down. That's your longitudinal lines. And then you have your altitude, which is how far away you are from the equator, or how high up you are. It's a measure of how high in the hemisphere or how high above the horizon an object is. It's a vertical measure from 0 degrees, which is the horizon, so that's 0 degrees. And then 90 degrees is going to be straight above, and then 180 degrees is behind. straight above is what we call zenith. That is the highest place in the sky. Zenith is straight up, wherever you are. That's your zenith. For example, the position in the sun in the sky can be given as altitude and azimuth of the sun for a specific time as viewed from a given location. At both sunrise and sunset, the sun is directly on the horizon, so the sun's altitude is 0 degrees. Between sunrise and sunset, the altitude of the sun is first increasing until it gets to 90, and then the altitude is decreasing because it's coming back down to the horizon. The time when the sun is at its highest altitude, given from at a given location, is sometimes called solar noon or transit. So if we're talking about things in transit, that means they are at their highest point in the sky. So, questions to think about: describe and draw a diagram where on the celestial sphere the sun appears to be if an azimuth of 120 degrees and an altitude of 10 degrees. If the sun is 2 10 degrees to the left of west, what is the azimuth? Okay, so remember our fists measurements. Fist is about 10 degrees in the sky. That's it.